Hello everyone, my name is Rohit Singhal and we were discussing about the topic hydrocarbons. In the previous classes, we were discussing about the aromatic hydrocarbons, the chemical properties of it. I have discussed the electrophilic substitution reaction, that are the major properties of chemical properties of an aromatic hydrocarbon. We have discussed the nitration reaction. So, the reactions till now we have discussed are nitration reaction, second we have discussed halogenation reaction, sulfonation reaction, then we discussed Friedel-Crafts reaction. Two Friedel-Crafts reaction we have discussed, alkylation and acylation. Alkylation has RC double bond O, positive carbocation is called acyl carbocation and it is R positive carbocation. Few limitations I have discussed in Friedel-Crafts alkylation reaction, that is the one is rearrangement of carbocation, that is electrophile. Second one is possibility of polyalkylation, and in this no such rearrangement and polyacylation. So, sometimes this acylation, Friedel-Crafts acylation is the more favored reaction. Halogenation reaction also can actually can undergo the poly, we can say, substitution. If I discuss the poly substitution, there is a possibility that if I react this benzene, let us say, with 6Cl2 using anhydrous AlCl3, so all of the hydrogens get substituted by the chlorine, and this is known as hexachlorobenzene. Okay. So, there are examples of this poly substitution reaction which we normally see in halogenation reactions and in alkylation reaction. So, now one although these reactions are not that much controllable as the Friedel-Crafts acylation reaction, but what can be the remedy for it? The remedy for it is use benzene in limiting amount, in excess amount. Okay. Use benzene in excess amount, or we can say, or use the electrophile generating species in limiting amount. Okay. That means not to use too much excess of Cl2, or not to use too much of alkyl chloride. So, it will give the polyalkylated or polysubstituted product. So, this must be taken care of while doing the alkylation reaction or the halogenation reaction. Okay. So, this was about the substitution reaction. I have already said that it do also undergoes some kind of addition reaction also, though very rare, but under certain conditions benzene undergoes some of the addition reactions. Now, what are those reactions is, if I react it with the hydrogen molecule, it can, under the high heating conditions and nickel as a catalyst, it can form cyclohexane. High temperature pressures needed for these addition reactions. High temperature, pressure and catalyst needed. So, these reactions, to perform this reaction, high temperature and high pressure needed, catalysts are needed. So, these can undergo this substitution, sorry, the addition reactions. Similarly, it can form like this also, UV and 500 K Kelvin. Hexachlorohexane, or we can say cyclo. This all the hydrogens, so means the double bond has been replaced. In this case, the double bond has been replaced all of the hydrogens, and in the other cases replaced by the chlorine molecules. Do you remember in the previous case which I have discussed about the poly substitution product? There I am using the 6Cl2 using anhydrous AlCl3, and we were getting like this. All of the hydrogen was substituted. This is different from what I am forming like now. This is a cyclohexane ring, this is a benzene ring. In that, all of the hydrogen being substituted by the chlorine molecule. In this case, where I am using the addition reaction, all of the double bond get the Cl2 molecule getting added on the double bond, C double bond C. Okay. The other reaction can be as all normal hydrocarbons, that it undergoes the combustion reaction. We use oxygen, and it will give carbon dioxide and water. Now, to balancing it, 6. Okay. So, this will be the balancing of the reactions. Okay. So, as normal hydrocarbons, these can undergo the under the combustion reaction in presence of, means heating in presence of the oxygen, and it will give the carbon dioxide and water as the products. Okay. So, this concludes the chemical properties of the benzene molecule. Now, there are a few other properties regarding to the chemical properties only. That is few things called as directing group. Something called as directing group in benzene. If you do remember, in the previous class I have discussed one thing, that there is a possibility of polyalkylation in case of polyalkylation in Fieldcraft alkylation. Okay. Now, you must be seeing that the other CH3 that I am substituting is opposite to the one which already substituted CH3 group. Now, what actually happens is, when I am substituting this benzene with CH3Cl, all of the protons are equivalent. Each proton is equivalent, or we can say all protons are same. But what happens is, on substituting any one of the hydrogens by an electrophile, what happens is, now these two hydrogens which are closer to this electrophile, okay, these two have a different environment. The electrophile is closer to these hydrogens. So, these two hydrogens are of one kind, whereas these two hydrogens, means the electrophile is the equal distance to the hydrogens. So, these two hydrogens are of different type, and thus remaining this hydrogen, and this remaining remaining one hydrogen is of different type. So, on substituting one hydrogen by an electrophile, three kind of hydrogens form, three type of protons. Okay. Now, these three type of protons, that means three different names to this. Okay. The red one, which are means the red one which are adjacent to proton adjacent to group are called orthohydrogens. That means, this position where that carbon is just adjacent to the electrophilic or the substituted carbon, that is known as orthohydrogens. The other one, proton, after that ortho hydrogens are called meta hydrogens. So these are called as the meta hydrogens. And the remaining third one, that is of another different kind, that is known as opposite to group, substituted group, is called as para hydrogen. Okay. So there are three positions whenever a hydrogen is being substituted by any one of the group. So there are three positions forms. One is ortho position, another one is meta position, third one is para position. So that means now these protons are not all of these protons are not equivalent. Now if I want to react this with CH3Cl, now it will depend ki the upcoming electrophile which go over the which place. So there are three possibilities. It can go, this is ortho, this is meta, and this is para. Now which hydrogen will be substituted is will depend on which kind of earlier substituted group is present. Now which among these will be formed, it will depend on already substituted group present. That which already substituted group is being present over that benzene molecule will depend that the next incoming electrophile will go over to the which position. So this substituted group actually are of two types. So the groups, these substituted groups first one is ortho and para directing group, and the second one is meta directing group. This ortho and para directing group is often called as the activating groups. And these are called the deactivating groups. Okay. Now which are the ortho and para directing groups, which are the meta directing group, and how we will differentiate between these two. Okay. So these two kind of product, that means ortho and para directing group. First of all, what this group does, let us suppose there is already an electrophile, then this is an ortho and para directing group. So what will happen if an second electrophile, another incoming electrophile will be, this means there are two possibilities, either it will go to the ortho position, means the incoming electrophile the next incoming electrophile will go over the ortho position or the para position, means these two possibilities these have. Whereas in case of meta directing group, that means an already existing electrophile and this incoming new electrophile, this already existing electrophile will direct the new incoming electrophile to the meta position of it. And which position is meta? This is ortho, this is meta. So this will be the product. Okay. So, these are the two kind of groups, ortho and para directing groups, that is called the activating groups, and second one is called meta directing groups, that is deactivating groups. Okay. Now, how these are para directing and how these are ortho and para and meta directing groups, that we will discuss. First we can say first we will discuss activating groups. Okay. Let me tell you first one thing. Generally what happens is, when a benzene molecule, when an electrophile is being present there, okay, and this electrophile is giving its electron density giving its electron density towards the benzene ring. That means that already it's not to be the, I am saying it's not to be the any electrophile, it can be a nucleophile also. So, let me being presented by the, let us say, a molecule A group. Okay. Okay. Now, this A group is donating its electron density to the benzene ring. For example, take an example of phenol. Make a bigger ring. It has 2 lone pair of electrons oxygen. So, what will happen, that it will give its electron density towards the benzene ring, and what it will form, a minus charge over here, double bond OH positive. This will again go on the resonance, and this will go over this, and this negative charge will circulate in the entire ring. This negative charge will circulate over the entire ring, and just do look after the positions on which this negative bond or negative charge is being circulated over the ring after finally reaching back to the oxygen, forming a lone pair and a double bond. And you see this resonating forms have been shifted towards 1 and 2nd. Okay. So, now what is happening is, in this resonance the negative charge is formed okay. What happens is, in this case you say ortho position negative charge is formed, this is para position negative charge is formed, again ortho. Okay. So, what actually happening is, in this case, that the ortho and para position are getting negative charge in case of this resonance. So, what happens is, electron density at ortho and para positions increases by the presence of activating groups. Okay. And this activating groups increases the electron density, that which in turn is more liable, or we can say is more available, or we can say more reactive towards incoming electrophile. That means, whenever there is an activating group present, it increases the electron density on ortho and para positions by generating a negative charge over there. These I have shown by the resonance. So, the ortho and para position electron density increases. If the electron density over ortho and para position will increase, that means an electrophile will tend to go over the ortho and para position instead of this meta position. That is why the group is present which is activating the group, which is activating the ring, that means which is giving the electron density towards the benzene ring, it will have the ortho and para substituted group, that is the activating groups. And this is also called as plus R effect, plus resonance. Plus resonance means the group is giving its electron density towards the ring. The activating groups such as OH, or we can say NH2 or we can say OH, NH2 or something like CH3 is alkyl groups. Okay, groups like OCH3. Okay, these groups are like the examples of the activating groups. That means okay, and you just see how you will distinguish which group is whether you have to learn this or not. Just don't learn it, just do care of one thing, that whichever group will be a activating group will have a lone pair, means with the atom directly attached to the benzene ring, the atom directly attached to the benzene ring will have a lone pair of the electrons. OH have lone pair of electrons, NH2 have lone pair of electron, CH3 don't have lone pair of electron, but it actually have the hyper it's a no bond resonance kind of thing, hyper conjugation. So this kind of thing, no bond resonance, and this OCH3 also have a lone pair of electrons. So that's why these activates the group to further initiate the incoming electrophile towards the ortho and para positions. Now what are the deactivating groups, that we will discuss in the next class. Thank you.